All right, so this video is going to go over this reading packet, the Superclass and Subclass Constructor, and then when we're done, I'm gonna go over this inheritance practice quiz. All right, so without the reading and lecture, a lot of this practice quiz stuff doesn't make sense. It's actually not that difficult, but there are some things that you're going to have to memorize, okay? So anyway, this is going to look at the superclasses and subclass constructors, all right? So I'm going to go down to where it says code listing 9-5, and I'm going to basically just read through this document, all right, and go through examples on here. So it says code listing 9-5 shows a class, a superclass 1, that has a programmer-defined no-arg constructor, okay? So that's this down here. Public superclass, no args, meaning no parameters are being passed, okay? The constructor simply displays the message, this is the superclass constructor. Code listing 9-6 shows the subclass 1, which inherits from superclass 1. This class also has a programmer-defined no-arg constructor, which displays the message, this is the subclass, okay? So right there, this is the subclass, subclass 1. Subclass 1 extends the superclass 1, so this is a subclass, that's a superclass, okay? The program in code listing 9-7 creates a subclass 1 object. As you can see from the program output, the superclass constructor executes first, followed by the subclass constructor. So right here, this would be your main, and you create a subclass OBJ object from the subclass 1 class. So then the output, when you create this is a superclass constructor, and then this is a subclass constructor. So what's going on here? So first thing to remember, the superclass's no argument constructor always gets called first, okay? Even though there's nothing in this subclass 1 constructor, let me get in here and use this real quick. Even though you don't see it, what Java does right here, without you even knowing it, it calls so if there's no argument, no arg constructor, the superclass's no arg constructor automatically gets called by doing this. Most of the time you have something like this and there's nothing even in here. It's just blank, and that's happening behind the scenes as well. So if you don't see a no arg constructor, then it's happening behind the scenes, whether you like it or not, and then there would be nothing in it. You know, it would just look like that, okay? So when we create this object, this actually gets called first, so let's do some erasing. This, without you knowing it, and this is why this is confusing and you have to memorize this, this, you know, super is happening behind the scenes, and when it does that, it goes up here and it calls this one, this displays, and then afterwards that displays. Okay, and so that's why your output is this right here, the output. This is a superclass constructor, this is the subclass constructor. So you just have to kind of memorize that the superclass's no arg constructor always gets called, and then you do the subclass's constructor next, okay? So let's read this. Inheritance does not work in reverse. In an inheritance relationship, the subclass inherits members from the superclass. not the other way around. This means it is not possible for a superclass to call a subclass's methods. Okay, subclass calls superclass, not the other way around. Okay, definitely have to memorize that. Calling the superclass. The super keyword refers to an object superclass. You can use the super keyword to call a superclass constructor. So in the previous section, you learned that a superclass's default constructor, a no-arg constructor, is automatically called just before the subclass's constructor executes, and that's where we saw the output on the second page. Okay. But what if the superclass does not have a default constructor or a no-arg constructor? Or what if the superclass has multiple overloaded constructors and you want to make sure a specific one is called? In either of these situations, you use the super keyword to explicitly call a superclass constructor. The super keyword refers to an object superclass and can be used to access members of the superclass. So in listing 9-8, shows a class, superclass 2, which has a no-arg constructor and a constructor that accepts an int argument. Code 9-9 shows subclass 2, which inherits from superclass 2. The class's constructor uses a super keyword to call the superclass's constructor and pass an argument to it. Okay, so we're going to see this right here. So we got superclass 2. We've got a no-arg constructor. This is the superclass, no args, and then we've got one that accepts an integer argument. Okay, the following. Okay, so subclass 2 passes 10 into this one. Okay, so let's look at this real quick. In subclass 2 constructor, the statement in line 7 calls the superclass constructor and passes the argument 10 to it. Here are 3 guidelines you should remember about calling a superclass constructor. The superclass or the super statement that calls the superclass constructor can be written only in the subclass's constructor. So you can only use super in the subclass constructor. You cannot call the superclass constructor from any other method. So you can only use super to call the superclass constructor in the subclass constructor. Okay, you can use super in a different method, but it will never call the superclass constructor. Okay, the super statement that calls the superclass constructor must be the first statement in the subclass's constructor. So this must be the first statement in here. This is because the superclass's constructor must execute before the code in the subclass's constructor execute. So you'll see multiple choice questions where the word super is used after, different statements in the constructor, and you can't do that. The super has to be the first one in the subclass's constructor. Okay, so let's look at this. So this, we create a subclass 2. The following argument was passed to the superclass constructor. So let's go back up into this code. 10 gets passed into here. The following argument was passed to the superclass constructor, and then 10 would display. Okay, which is what we see. And then the subclass constructor gets called. This is the subclass constructor, and that's where that displays next. Okay. Let's see here. When the superclass has no default or no argument constructor. Recall from Chapter 3 that Java provides a default constructor for a class only when you provide no constructors for the class. This makes it possible to have a class with no default constructors. Okay, so again, when you create a new object, where is it at? Let's see. When you create a new object like this, it has to have some sort of default constructor. Even if you don't see it, it's there. Like in this one, in this subclass, here's the default constructor, and it has information in it. But even if you don't see it, you know, when you run a line like this, you have to have some sort of default constructor because it's saying it's a new subclass of 2. It has to have a constructor even if you have nothing in it. In this case, this has stuff in it, but imagine if this had nothing in it. It sits in the background even if you don't see it, okay? So if a superclass does not have a default constructor and does not have a no-arg constructor, then a class that inherits from it must call one of the constructors that the superclass does have. If it does not, an error will result when the subclass is compiled. So here's a summary. What we've covered. The superclass constructor always executes before the subclass constructor. Okay, and again, you may not even have it programmed in, but it's still being called. It has to call it, okay? You can write a super statement that calls a superclass constructor, but only in the subclasses constructor. Okay, again, that's where your inheritance goes up, you know, in your ISA relationship. You cannot call the superclass constructor from any other methods. Okay, we know that. So if a statement that calls a superclass constructor appears in a subclass constructor, it must be the first statement. So the super statement, if it's in a subclass, it has to be the first statement. If a subclass constructor does not explicitly call a superclass constructor, Java will automatically call super this. Even if it's not plugged in on your computer, it's happening behind the scenes. That's pretty darn confusing, so you have to memorize that. Okay, and that's what it was doing, I believe, in the first one, right up here. Okay, do you see super in here at all? No, it's not there, but it's still automatically being called. Again, very confusing. Before I found this book, I had to figure this out on my own, and it made 0 sense to me when I was learning this stuff. And I didn't have a teacher to tell me how this works, so I had to, you know, search for it all online and everything. So memorize this. If a superclass does not have a default constructor and does not have no arg constructor, then a class that inherits from it must call one of the constructors that the superclass does have. Okay, so these are things that you have to memorize, and these are 5 good bullet points, and I demonstrated all of them in here. So you might want to go through and read these again if you need to. I'll post these right before the practice quiz that we're going to start doing, okay? Okay, so the practice quiz. We've got a bank account, and it's got a default constructor. It's got a constructor that has a parameter balance. It's got a deposit, withdrawal, and get balance. Okay. My balance is private, so it can't be changed anywhere else in savings or checking account, but it has a public method, get balance, where you can get the balance, okay? And you can change it through its public methods, deposit and withdrawal. So down here you could deposit, withdraw, and use those. So savings account extends bank account. It has a savings account default constructor, has a savings account that gets the balance and the rate, and it adds interest. So savings account has access to add interest, get balance, because we're extending bank account. It can add interest, get balance, withdrawal, and deposit. So it's got 1, 2, 3, 4 methods it can access, okay? Checking account has it extends a bank account, so the checking account has access to deposit, withdrawal, and get balance, and it can withdraw money from the checking account. So it has access to 1, 2, 3, 4 different methods, all right? Now, does checking account have access to add interest? No, absolutely not, because a checking account is not a savings account. a checking account is a special type of bank account, and a savings account is a special type of bank account. But a savings account can't use this checking account withdrawal. It has to use the bank account withdrawal. And the checking account can't use the add interest because you don't earn interest in a checking account. Okay, so of the methods shown, how many different non-constructor methods can be invoked by a savings account? Well, I already did this. So savings account has 1, 2, 3, 4 methods it has access to that aren't, they're non-constructors. Okay, so the answer for 1 is D. 2, which of the following correctly implements, just getting something to drink there. 2, which of the following correctly implements the default constructor of the savings account class? Well, remember, super has to be used before any of these if you're in a constructor, so 1 doesn't work. That would create an error. Let's see here. Which of the following correctly implements the default constructor of the savings account? Well, this one would work. Okay, and this 2 and 3 work. So bank account has a balance. Savings account has a balance and a rate. So you can call super. Oh, the default constructor. Okay, cool. So this one will work too. 2 and 3 works. Look at this. If we had the default constructor right here, we can just call super, and that would work. That would super in. That would call this guy first, and it would initialize my balance to 0. But then I can also, the rate isn't being passed in here, but we can create my interest rate and set it to 0 in here. So 2 and 3 both work fine. Okay. Sorry, at first I didn't look at the default constructor. That kind of skipped my mind. So anyway, yeah, 2 and 3 work. 3, which is a correct implementation of the constructor with the parameter. Okay, so for the savings account, we're looking at this one. So we've got balance and rate being passed in. Now, balance needs to be supered in. That's the whole point of inheritance in object-oriented programming, is that balance got passed into bank account, and a savings account is a bank account. So we pass this in, we need to super that in, and then rate is special to the savings account. So A looks right on here, but it doesn't do inheritance. So just by looking at this, I mean, this should be easy. We're supering in the balance and then my interest rate, the rate. Don't screw it up with A, though. A looks right, but again, you're using inheritance. So since balance is used in the bank account class, you need to super it in. The other ones won't work because this would call the default constructor, and balance isn't part of the, being passed in is part of the default constructor, so it's not doing anything. This one, yeah, again, balance isn't being supered in. And D, this kind of looks correct because balance is being supered in, but rate isn't part of bank account, so rate can't be supered in. So your answer is definitely D. So 4. Which is the correct implementation of the checking account constructor? So, let's see here. Ooh, this is a good one. So 4, checking account. So there's my checking account. It takes the balance from the bank account. So can it needs to super in balance. So 1 works. 2, yep, we can super in from the default constructor, but look at this, deposit balance. Balance gets passed in, and then you can deposit it. This one works. This one's good. And 3 is the same thing as 2, because remember, if you don't call the super, the default constructor super, it will do it for you automatically behind the scenes. So that's kind of a trick one. So your answer for this is E, 1, 2, and 3. Okay. 4, which is the correct implementation for the code withdrawal? Okay, so withdraw, this withdraw over, so when you call a checking account object, this withdraw out runtime would override this withdraw. Okay, it's a special type of withdraw where we want to fee of $2 deducted if the withdrawal leaves balance less than the minimum balance, allows for a negative balance. Okay, so let's see here. Super withdraw amount if balance is less than. Are A and C the exact same? Ooh, look at that. I'm just kind of comparing these. If my balance is less than minimum balance, all right, so A, look at the difference. So this is good. We withdraw the amount, calling this the withdrawal from the superclass, and we withdraw the amount. And then we say if my balance is less than minimum balance, then we super withdraw the fee. Okay, the only difference between A and C is this right here. Now, the big question is my balance private. Bam. My balance is private. So can the checking account class access my balance? Well, it can, but it can only do it through its public methods. Public double get balance, and it returns my balance. So you can't, so this is a really good one. So A does not work because the checking account can't access the variable my balance directly. It can only access through the public methods of the superclass. So A does not work, but C is correct. D, withdrawal amount. Okay, why would that not work? Because it doesn't call the superclasses withdraw. And you've got the same issue as A with my balance. Can't do that. D, same thing. Can't, you know, what would be the point of calling, you know, the withdraw from, that'd almost be like a weird version of recursion. So that won't work. Yeah, you don't ever super, so you need to super it from the superclass. And again, you can't access my balance, so that stuff doesn't work. So your answer is C. Okay. Let's see here. Short answer. A small zoo has both animals and birds, goats that bleat and eat grass, pigs that squeal and eat swill, turkeys that gobble and eat grain, elf owls that hoot and eat insects, snowy owls that hoot and eat either hares, lemmings, or small birds, whichever are available. Suppose you were to write a program that simulates the zoo. Draw a diagram that represents an animal class hierarchy. Your diagram should show the relationship between all the objects in the program. with animal as a superclass for all the other objects. Each class in your design should be represented by a labeled rectangle and arrows that show the inheritance relationship. Okay, so I did that right there. So you got an animal, mammals, and then birds. Goats and pigs are both mammals. Owls and turkey are types of birds. And a snowy owl and an elf owl are both owls. Okay, B. The animal class, it's got a private variables, all strings, my name, my noise, my covering. There's the animal constructor. You can get the name, get the noise, and get the covering. Get the food. We'll learn more about abstract constructors later, or abstract methods later. Given the code for the bird class below, write the... Okay, so birds accept name and noise. And so let's look at this. So we've got name, noise, and covering. So name, noise, and feathers are both all supered in here because they're inheriting from animal. And so you can super in the name, noise, and the feathers. An owl, a bird, an owl is a bird that hoots. The food it eats depends on the type of owl. Assuming that the animal and bird classes have been correctly defined, write the owl class below. Now look at a bird's got a name and a noise. So all we have to worry about for the when we super in is the name and the noise for the owl. So public owl, we pass in the name. We can just say name, and then we can just say it hoots. You know, you could pass in, you know, instead of doing it like this and having hoot, you could also pass in string noise, and then instead of hoot, it could just be noise right here. Either way, that's fine. All right, cool. Go through this quiz. Make sure you understand the answers. If you need to go back and look at, you know, the readings that I gave and went through, go ahead and do that. But this video is done.